Imagine you are standing under a clear night sky. You can see countless stars twinkling above you. They look like tiny, peaceful diamonds scattered across a vast, dark velvet cloth. For thousands of years, we have looked up at these stars and wondered. We have told stories about them, named them, and used them to find our way. But in the grand, silent theater of the universe, things are not always as peaceful as they appear. There are dramas unfolding on a scale so immense that it is almost impossible for our minds to grasp them. These are not quiet stories. They are tales of incredible power, violence, and breathtaking beauty. Out there, in the deep darkness between the stars, something invisible is lurking. It is a monster of gravity, a cosmic predator of unimaginable strength. It does not shine, it consumes light. It does not make a sound, yet its presence can tear apart entire solar systems. This monster is a black hole. And sometimes, by a twist of cosmic fate, the path of a star and the path of a black hole are set to intersect. This is not a gentle meeting. Before we can watch this cosmic drama unfold, we must first get to know our main characters. On one side, we have the star. On the other side, we have the black hole. A black hole is not a hole in the traditional sense. It is not empty space. In fact, it is the exact opposite of empty. A black hole is an object of unimaginable density. According to Einstein's theory of general relativity, mass warps the fabric of space-time. Think of space-time as a stretched-out rubber sheet. If you place a bowling ball on it, the sheet will dip and curve. This boundary, this point of no return, is what scientists call the event horizon. It is not a physical surface you could touch. It is simply the threshold in space where the gravitational pull becomes insurmountable. Crossing the event horizon is like going over a waterfall in a boat with no engine. Once you pass that edge, your fate is sealed. Most black holes are surrounded by a swirling vortex of matter that has been drawn in by their immense gravity. This is called the accretion disk. Not all black holes are created equal. When astronomers look out into the universe, they see them in primarily two different sizes. The first kind is the stellar mass black hole. These stellar mass black holes are the direct result of the death of a single massive star. When a very large star runs out of fuel at the end of its life, it can no longer support its own weight. This collapse triggers a cataclysmic explosion known as a supernova, which blasts the star's outer layers into space in a brilliant, beautiful display. The second flavor is far more monstrous, the supermassive black hole. These are the undisputed kings of the cosmos. They are giants with masses ranging from millions to billions of times the mass of our sun. We have discovered that these behemoths are not rare. They seem to be a standard feature, lurking in the center of almost every large galaxy we have ever observed, including our very own Milky Way. The origin of these supermassive black holes is one of the biggest puzzles in modern astronomy. They are simply too big to have been formed from a single star dying. Now that we have met our two cosmic players, we can set the stage for their dramatic encounter. In the quiet outer suburbs of a galaxy, stars can live out their entire lives without ever being bothered. But the centers of galaxies are very different places. They are not quiet suburbs. They are bustling, chaotic, and crowded cosmic cities. Here, millions of stars are packed together in a relatively small volume of space. They are all swirling at incredible speeds around the galaxy's central point. A star might be minding its own business, on a stable orbit far from the center. But then, a slight nudge from a passing star or a giant gas cloud could be enough to alter its path. This tiny change in its trajectory could send it on a new elongated orbit, one that takes it on a perilous dive right towards the galactic core. The star is now doomed. As the star begins its fateful plunge, it picks up incredible speed. It accelerates towards the supermassive black hole, pulled in by the ever-increasing force of gravity. The first crucial boundary the star approaches is not the event horizon itself, but a region known as the Roche limit. This is an invisible sphere of influence around the black hole where its gravitational power starts to become truly destructive. What are these tidal forces? You are actually familiar with them here on Earth. The moon's gravity pulls on the Earth, and it pulls slightly more strongly on the side of the Earth facing it than on the side facing away. Now imagine that effect amplified by a factor of 1 billion. A supermassive black hole exerts a gravitational pull that is unimaginably powerful. As the star gets closer, the pull on the near side of the star is vastly stronger than the pull on its far side. The star, which has maintained its proud spherical shape for its entire life, begins to distort. It is stretched out, elongated along the direction of the black hole. It starts to look less like a ball and more like a cosmic egg or a teardrop. This is the very beginning of the end. The star's own gravity is losing the battle, and the immense power of the black hole is starting to rip it from limb to limb. As the doomed star plunges deeper past the Roche limit, the tidal forces intensify with terrifying speed. The star is literally being turned into a cosmic noodle of superheated plasma. The once mighty sun, a powerhouse of nuclear fusion that shone for eons, is being unraveled like a ball of yarn. All its mass, all its history is being strung out across millions of kilometers of space. This process is both methodical and violent. It is not an explosion that happens all at once. Instead, the star is carefully and completely dismantled. The side of the star closer to the black hole is pulled away first, forming the leading edge of this stellar stream. The rest of the star's material follows behind, a river of gas flowing towards the abyss. The tidal forces compress the stream, heating it up through friction and pressure. The gas that once made up the star's quiet core and its outer layers is now a turbulent, glowing river of plasma, heated to millions of degrees. This process transforms the star from a single, bright object into a vast, luminous ribbon wrapped around the black hole. A star that took billions of years to live would be completely unmade in less than a day. The destruction of the star is not a quiet affair. This process unleashes an enormous amount of energy, creating a brilliant cosmic flare that can be seen from across the universe. Astronomers call this a tidal disruption event, or TDE. This is the star's final luminous scream before it is consumed. The flare of a TDE is one of the most powerful and dramatic light shows the cosmos has to offer. For a few months, the light from this single dying star can temporarily outshine all the other billions of stars in its host galaxy combined. This incredible brightness comes from the intense heat generated during the star's destruction. When our telescopes suddenly detect a brilliant new source of X-rays where there was none before, it is a telltale sign that we may be witnessing a TDE. The light from a TDE has a very specific signature that helps astronomers identify it. It typically rises to peak brightness very quickly, over a matter of weeks, and then fades away more slowly, over a period of months or even years. By studying the details of this light, scientists can piece together what happened. They can estimate the mass of the star that was destroyed and even the mass of the black hole that did the destroying. After the star has been shredded into a long stream of gas, its story is not quite over. About half of the material in the stream is on a trajectory that will eventually carry it away from the black hole. But the other half, the inner part of the stream, is captured. However, it does not fall in directly. Instead, it begins a long, spiraling journey inwards. It is like water swirling around a drain. The stream of gas begins to loop back around the black hole, colliding with its own tail. This massive collision and the intense gravitational forces cause the stellar debris to flatten out. This forms a new, temporary structure around the black hole, an accretion disk. This is the cosmic dinner plate from which the black hole will slowly feast. This newly formed accretion disk is an inferno of light and energy. As the gas spirals closer and closer to the event horizon, it moves at incredible speeds, approaching the speed of light. The friction between different layers of gas moving at different speeds is immense, heating the disk to millions of degrees. It glows fiercely, releasing a torrent of radiation across the entire spectrum. The story of a star being torn apart by a black hole is not just a wild theory or a computer simulation. It's actually a real phenomenon that astronomers are now witnessing across the universe. The key has been the development of automated all-sky surveys. These are robotic telescopes that scan the entire night sky, every single night, looking for anything that changes. They act as our cosmic security cameras. Projects like the Zwicky Transient Facility take millions of images, and powerful computers compare them to previous night's data. They're searching for transients, new points of light that suddenly appear and then fade away. Most of these are distant supernovae, but every once in a while they find something different. they find a flare with the unique signature of a TDE, a rapid brightening followed by a slow, steady fade, coming from the exact center of a distant galaxy. When one of these automated surveys gets a promising hit, an alert is sent out to astronomers all over the world. It's like a cosmic fire alarm. Scientists then scramble to point other, more powerful telescopes at the location. They use space-based observatories like the Swift satellite to look for the telltale X-rays and ultraviolet light, and large ground-based telescopes to study the visible light in detail. Sometimes, the aftermath of a tidal disruption event includes even more dramatic phenomena. The intense magnetic fields in the spinning disk can act like a cosmic particle accelerator, creating colossal jets of plasma that are blasted away from the black hole's poles. These are focused, high-energy fountains of matter, traveling for thousands of light-years out into the surrounding galaxy. The powerful jets can carve out huge bubbles in surrounding space and influence future star formation. The rest of the stellar material meets a much quieter but more final fate. Over a period of months to years, the gas in the accretion disk slowly loses energy and spirals inwards, eventually crossing the event horizon. The entire event leaves a lasting mark on the galaxy. The half of the star's material that was flung away enriches the interstellar medium. And the black hole itself is now slightly more massive than before. It is a stark reminder of the constant cycle of creation and destruction, a violent and beautiful drama playing out on the grandest of all stages. For a time, the center of the galaxy is lit up by the memory of the star's passing. The feast is finally over. Reflecting on the immense power and scale of a star meeting, a black hole naturally leads us to consider our own place in this grand cosmic theater. We live on a small, fragile planet orbiting a rather ordinary star, tucked away in a quiet spiral arm of the Milky Way galaxy. We're safe, located in the quiet suburbs, far from the chaotic and crowded downtown district of our galaxy. This location is not an accident. It's likely a crucial reason why life had the long, stable period it needed to evolve and flourish here on Earth. Our quiet cosmic neighborhood has provided us with a stable platform from which to observe the universe's more violent dramas. We're like spectators sitting in the comfortable seats of a theater, watching a spectacular and dangerous show unfold on a distant stage. This unique position gives us both security and perspective. We're close enough to the action to see it with our incredible telescopes, but far enough away to be safe from the fallout. The atoms forged in ancient stars have assembled in such a way that they can now build telescopes to look back at those stars, and brains to comprehend their life cycles. This is perhaps the most wondrous fact of all. We are an active part of the universe becoming aware of itself. The consciousness that evolved on this planet has enabled the cosmos to be seen, to be understood, and to be appreciated. As we conclude our exploration, it's clear that the story of stars meeting black holes is far from over. In fact, we're standing at the dawn of a golden age of discovery. New and more powerful telescopes are coming online, both on the ground and in space. The Vera C. Rubin Observatory, for example, is poised to change the game entirely. When it begins its survey, it'll scan the entire visible sky every few nights, discovering thousands of new transients. So the next time you look up at the night sky, remember the hidden drama unfolding in the deep darkness between those peaceful-looking stars. The universe is telling a spectacular story, and our journey to understand it is one of the greatest adventures humanity has ever undertaken. The journey has just begun.